Hello, my dear students, and a very warm welcome back. I know, exams are just around the corner, and sometimes this chapter, the theory of consumer behavior, it can feel a little complicated. But trust me, don't you worry. In just the next few minutes, we are going to make this so simple that you will feel absolutely confident. So let's jump right in.
First things first, let me ask you a question, and be honest. Have you ever felt this? You're scrolling through Instagram, you see that new phone, those cool shoes, a vacation your friends are planning. Your wants list is huge, right? It feels like it's in the lakhs. But then you check your pocket money and it's in the hundreds. That feeling, my dear students, that exact problem is where all of economics begins.
So to really get this, let's start with part one, our wants versus our pocket money. We need to understand what we want and why we want it. And to make it super easy, we're going to follow the story of a student, just like you. Let's call her Ria. Now, in your textbook, you'll see a big, fancy word, utility. Don't let it scare you. Utility is just another word for Khushi. You know, the happiness or the satisfaction you get from something. For our friend Ria, her two favorite things are a plate of hot momos and a cool glass of lassi. That feeling she gets when she has them, that's utility. Simple as that. Okay, just imagine this. Ria eats her first plate of momos. Oh, the Khushi is at its peak. So much happiness. Now, she goes for a second plate. It's still yummy, for sure, but that extra happiness she gets, it's a little less than the first one, right? By the time she gets to the third plate, she's like, okay, I'm getting a bit full now. The extra Khushi is even smaller. And if someone tries to make her eat a fourth plate, oh my God, bus, no more, please. The happiness might even turn into unhappiness. This, my friends, is the famous law of diminishing marginal utility. The extra or marginal satisfaction you get from each extra unit, it keeps going down. So Ria knows what makes her happy. But can she just keep eating momos forever? Of course not. Her pocket money is the boss here. And that brings us to the reality check, part two, what she can actually afford. Let's call it the can't cross line.
Let's say Ria gets a weekly pocket money of 100 rupees. Now this isn't just a number, it's her total income, her budget. For this whole week, that 100 rupees is her entire world of spending. It's a hard limit. She absolutely cannot cross it. Not even by 1 paisa.
Okay, so she has her money. Now she goes to the market and sees the prices. Momos are 20 rupees a plate, and lassi is 25 rupees a glass. These prices are set by the shopkeeper. She can't really bargain or change them. So now she has two things, her budget of 100 rupees and the prices of the things she wants.
So with her 100 rupees and with these prices, we can actually figure out all the different combinations of momos and lassis she can possibly buy if she spends every single rupee. This collection of all possible combinations, we give it a name, the budget line.
And here it is. This line on the graph is her limit. She can buy any combination that's on this line, or anything inside it. For example, she could buy 5 plates of momos and 0 lassi, or maybe 4 glasses of lassi and 0 momos, or some combination in between. But any point outside this line, no way. It's impossible with her budget. You can think of it like her Lakshman Rekha for spending. She just can't cross it. Okay, so we have what Ria wants, her Khushi, her utility. And we have what she can afford, her budget line. So now for the big question, the most important part. How does she pick the one combination that gives her the absolute maximum happiness without crossing her budget? Let's find out in part 3.
To solve this puzzle, we use another really cool tool. It's called an indifference curve. Again, don't worry about the name, it's very easy. An indifference curve is just a line that joins all the different combinations of momos and lassi that give Ria the exact same amount of happiness. She is indifferent between any of these points because to her, they all feel equally good.
Now, we can draw lots of these indifference curves, right? It creates something like a map of her happiness. And the rule is so simple. The higher the curve, the higher the level of Khushi. So naturally, what's Ria's goal? It's to climb onto the highest possible happiness curve that her pocket money will allow her to reach. So, here is the golden rule. This is what you absolutely must remember for your exams. The best, the most perfect choice for a consumer, what we call the optimum, is found at that one point where their budget line just touches or is tangent to the highest indifference curve they can possibly get to.
And look at this. This is the magic moment, the aha moment. See, her budget line can't reach those curves that are higher up, and the curves below it, well, they give less happiness. But this one special point, where her budget line just gently kisses the indifference curve, that is her best possible choice. That is the combination of momos and lassi that gives her the maximum Khushi for her 100 rupees.
So why did we spend all this time with Ria and her momos? Because this simple story perfectly explains the most famous, most important law in all of economics. In this final part, let's see how Ria's choice helps us understand the law of demand.
Let's just imagine for a second. There's a special sale on momos. The price suddenly drops from 20 rupees to just 10 rupees a plate. Wow. What do you think Ria's going to do now? Well, look at the graph. Because momos are now cheaper, her 100 rupees suddenly feel more powerful, right? She has more buying power. She can buy way more momos than before. So her budget line actually swings outwards. And because of that, she can now reach a new, higher indifference curve. She's happier, and her new best choice includes buying more momos. And now, for the final piece of the puzzle, let's just track Ria's choices. So at the first price, 20 rupees, she bought a certain number of momos. Then, when the price fell to 10 rupees, she bought a larger number. Now, if we take just these 2 points, price and quantity, and plot them on a new graph, and we connect them, what do we get? We get the famous downward-sloping demand curve. And what does this beautiful curve show us? It shows us the law of demand. It says that when the price of something falls, the quantity that people demand for it will rise, as long as other things stay the same. See? We figured out the most important law in economics just by following Ria and her pocket money problem. It's that simple.
Fantastic. You guys are doing so well. Now that you understand the big idea, let's do a super quick revision of a few other small topics that are very, very important for your exams. Ready? Let's go.
First up, normal goods versus inferior goods. It's really easy. A normal good is something you buy more of when your income goes up. You know, like good quality clothes or eating out at a nice restaurant. An inferior good is the opposite. It's something you buy less of when your income goes up because now you can afford something better. For example, you might switch from a coarse grain to better quality rice.
Next, we have substitutes and complements. Substitutes are goods you can use in place of each other. Think tea and coffee. If coffee becomes too expensive, you might just switch to drinking more tea. Complements are goods that go together, like a team. Think pen and ink, or shoes and socks. If the price of pens goes up, you'll probably buy less ink too, right? Okay, let's try a real exam question. This kind of numerical problem comes up all the time. So, a consumer's income is 20 rupees. The price of good 1 is 4 rupees, and the price of good 2 is 5 rupees. What is the equation of the budget line? Take a second, think about it.
And here's the answer. The formula is simply price of good 1 times quantity of good 1 plus price of good 2 times quantity of good 2 equals your total money, or M. So we just put the numbers in. 4 times x1 plus 5 times x2 equals 20. That's it. You write this in your exam and you get full marks. See? So easy. You are all going to do brilliantly in your exams. All the very, very best, study smart, and I will see you in the next one. Bye-bye.